Hello and welcome to the section 7.1 video. Today we're going to be looking at solving equations that have variables on both sides. A big thing that your book decides to use are these algebra tiles, which we will try to sort of mock up. We won't have them explicitly, but I'll do my best to help us kind of piece together what we're looking for when we're using these. But the main idea is, just that solving equations and trying to get our variable by itself, just the added piece that we have a variable on both sides. So in this first example, we're trying to solve x plus 5 equals 3x minus 1. We're trying to find what x has to be. And we use various algebra tiles, typically the sort of yellow orangish meaning a positive and the red being a negative. And then the vertical kind of bars are our x's and our individual pieces are our units. And the main idea is that a positive and a negative cancel each other out. So we model x plus 5 on the left side. And this would be like an algebra mat that has a line in the middle. That line is our equal sign. And maybe it's more important that that's in black. Okay, but that line represents our equal sign, and this is the two sides of the equation. And we want to keep them balanced. They're balanced right now, and that's the main idea behind algebra tiles is when you write an equation out, it's balanced. And whatever we want to do, we want to keep it balanced as we work. So it says to model x plus 5 on the left side, 3x minus 1 on the right side. That's done. 3x minus 1 is the same as 3x plus a negative 1. And that's an important idea in this working with algebra tiles and just working with expressions in general. Okay. It says that we want to remove one x tile from both sides. This represents subtracting x from both sides of the equation. So if I saw this as an x tile, so basically I'm going to, on both sides in a way, add in a negative x tile. So kind of like this, adding in this negative x tile on both sides, and these two cancel each other out, and these two cancel each other out. So then we're left with the 5 unit tiles on the left, and then we've got the 2x tiles and the negative 1 unit tile on the right. Okay, then on both sides we're going to add an additional unit tile. That's what this one is here, as well as this one here, and that represents adding 1 to both sides. And maybe we say adding 1 to both sides. So we took this and we went plus 1 on both sides of the mat. Okay. This gets to be removed as it's a 0 pair, and that's what they're saying here. They're not pointing down to this at all. This just gets to be removed, just like these did. Okay, we made 0 pairs out of everything. Okay, and then it says that we have, so at this point we have, over here is 6, and over here we have 2x. Maybe this helps represent what's happening. Maybe we do that for the whole thing. So here we have x plus 5 equals 3x minus 1. At this stage, we removed those, and we had, it looks like 5 equals 2x minus 1. And then we split them into equal groups. Since we have 2 x tiles left, we split our other side into even groups as well. And that's the equivalent to, 1 x tile is, okay, so one of these x tiles is the same as 3 of the plus 1 tiles. And so what that means is that one of the x tiles is equal to positive 3. Okay. Well, let's just kind of go back and see, what did we do? Okay, what did we do when we did this? Well, we got one side to not have any x's. So this side started with an x, and we found a way to get rid of that. And basically what they didn't do is that adding of that red x tile, or the -1 x tile, to both sides to get rid of it. Okay, so we got it to where, okay, it started with an x on both sides, or variables on both sides, and we made it to where the variables were on one side. Okay, and then we took that and we got rid of the units on the x side. Okay, we found a way to remove the units on the x side. We did that by adding 1 unit to both sides. And then we saw how many x tiles we had, and we split the left side into that number of that number of groups. And so that's kind of a logic way of how we did that, or a mathy way of how we did that. And then it says, how can you check the solution to x plus 5 equals 3x minus 1 using algebra tiles? We basically just did that. Okay. But it basically comes down to say that since there are, let's say since we have 2 x tiles, so since we have 2 x tiles, equaling 6 plus 1 tiles, each x tile has to equal 3 plus 1 tiles. Okay. Now let's look at, let's say we don't have our algebra tiles, our algebra mat, which is usually, I mean, especially right now, how we would do it. We want to find a way to solve these equations without that technology, or whatever you would call it, that manipulative. It says here that Andy's rental car charges an initial fee of $20 plus $30 per day, whereas Buddy's rental car charges an initial fee of $36 and an additional $28 per day. And we want to find the number of days that the total cost charged by the company is the same, for what number of days. So it really comes down to, we're going to know that one's cheaper than the other for a certain amount of time, and then one's going to overtake the other. We want to find what day do they overtake each other. We'll go later to find out which one's cheaper before, which one's cheaper after, but we want to find that kind of break-even point. So we come up with the two expressions by taking the initial fee and adding the cost per days times the number of days, or in this case, that number of days is going to be X. So for Andy's, we've got the $20 fee plus $30 per day, where X is the number of days. For Buddy's, we have 36 as an initial fee and 28 per day. And so to find out when those two are the same, we set them equal to each other, and then we solve that equation. So if you remember on the algebra tiles, the first thing we did was we had x's on both sides. We had the x tiles on both sides, and we want to make it to where we have x tiles on only one side. So you have two ways to do that. I could either put the x's on the left or on the right. In this problem, they choose to put the x's on the left. They take all the ones on the right and they subtract them on both sides. So 28x on here, we're going to subtract that from both sides of the equation. And remember, I want to subtract x's from x's. So 30x minus 28x is 2x. That's the same thing as making those zero pairs that we made on the algebra tiles, but you'd have a lot of tiles in this problem because you have 30x on this side, 28 on that side. So then once we have all the x's on one side, we want to take the units away from that side. So since I have the x's on the left, I want to get the units off of the left, the numbers off of the left. So since we had 20 here, we'll subtract that. 20 minus 20 is 0. And on the right side, we get 36 minus 20, which is 16. So we're left with 2x equals 16. So we divide both sides by 2, and we get x equals 8. Really, you've done problems from this point. So it kind of comes to, we haven't done problems with variables on both sides, so let's not have variables on both sides. The main strategy that I would always say is put your variables on one side, your numbers on the other, and then simplify, and then solve it, right? Either add, multiply, or divide, whatever you have to do to get the x by itself, or the variable by itself. But it turns out that in this problem, that after 8 days, the two companies cost the same. So then I could ask a follow-up question as to before 8 days, which company is cheaper, or after 8 days, which company is cheaper. But that's what it would turn out to be, is that 8 days is sort of that break-even point. So if you looked at this like on a graph, you would have, and I'm not going to speculate as to which one is which, but one company is cheaper for a certain amount of time, and then the other company is cheaper for a certain amount of time, or after a certain point. So I'd get two lines that, probably look like this. Well, they'd probably be a lot steeper than this, but it turns out that the point that they cost the same right here is at 8 days. Okay, and these lines would be a lot steeper, a lot more vertical. But just as a quick drawing, you've got, one company here, the other company here, and 8 days is sort of that break-even point. So if you're going to keep the car for 8 days, it doesn't matter. It doesn't matter which company you choose, but it does matter if you keep it anything other than 8 days. Okay. This one says a water tank holds 256 gallons but is leaking at a rate of 3 gallons per week. The other one holds 384 gallons but is leaking at a rate of 5 gallons per week. After how many weeks will the amount of water in the two tanks be the same? Same idea, that we're looking for a number of weeks, and you can always look to your question to find your variables. How many weeks? So let's use W for a variable. And I love that they give us absolutely no room to do this. Let's try to fit it in up here. So for the first tank, we have 256 gallons, and it's losing 3 gallons per week. The other one is 384 gallons, and it is losing 5 gallons per week. Okay. Same strategy holds though. I want to get all my variables on one side, all my units or numbers on the other side, and then multiply or divide to solve it, solve the remaining equation. Okay. So let's put all of our variables on the right. I don't know why, it doesn't really matter. You always get to choose, but I'm going to get all my variables on the right. So I'm going to take this negative 3w and move it over. The way I move things is add or subtract. If I don't want negative 3w's over here, I'll add 3w's to both sides. And so here I have 256. Negative 3w plus 3w equals 0. 384. And negative 5 plus 3 is negative 2 w's. Okay. Now I need to get my numbers on the other side. So instead of having 384 over here, I'll subtract that over. I move things by adding or subtracting. So I'm moving this over. And over here they cancel out. It might just be quicker to type this into a calculator than having to think too much. 256 minus 384 is negative 128. And negative 2w there. In order to get w by itself as our last step, we want to divide by negative 2. And negative 128 divided by negative 2 is 64. So after 64 weeks, both tanks will have the same amount. Then we could always ask, like, well, what is that amount? How much would they have? That's a whole nother problem. Okay? It uses the same ideas, but it is a whole nother problem. Okay, so writing real-world situations from an equation, we kind of just did that. Oh, no, we're doing the opposite now. We just wrote equations from real-world situations. This always kind of leaves a lot of openness, so it's not always the most easy thing to do, but it's a good thing to practice. It says write a real-world situation that could be modeled by the equation 150 plus 25x equals 55x. It says that the left side of the equation consists of a constant plus a variable. And so it could represent the cost for doing a job where there is an initial fee plus an hourly charge. The right side just has a variable. So maybe it's just a same job, but just an hourly charge. And it says that the equation 150 plus 25x equals 55x could be represented by the following situation. A handyman charges $150 plus $25 per hour for house painting, whereas a painter just charges $55 per hour, and after how many hours, or how many hours would a job have to be to take for the handyman's fee and the painter's fee to be the same? So, at what point is sort of that break-even point is the question. Okay. So writing one for this situation, it says that we have 30x equals 48 plus 22x. Again, get creative. Try not to use the same one that they use. I would think that I always think of like carnivals, different carnivals, and I might think of these as cents just to make it a little more realistic. But let's say one carnival charges 30 cents per ride. Let's not call them rides, let's go with games. So 30 cents per game. And we'll go ahead and go with while another. Charges a base fee. Since this one has a constant and a variable, the constant is the base fee and the variable has to be the per game amount. So a base fee of 48 cents and 22 cents per game. And the question comes to what's the break-even point? And the way that we would have to phrase that is something along the lines of how many games must be played to cost the same. The same amount. And you could elaborate that on that, like to say the same amount at each carnival. I just ran out of room. So something along those lines. And maybe it's an arcade. Maybe it's not carnivals. Maybe they're arcades. One has 30 cents per game. The other one has one of those little swipe cards where you first have to load it, and then each game costs so much, that kind of thing. So again, get creative, do what you can do. And that'll be it for today. I think a good code word for today, since we're really in the mindset of equations, has to be equation. I ran out of my creative juices, so that's all we've got. Other than that, make sure that if you have any questions, you please let me know. Otherwise, we'll see you in class, and have a good day.